So this video is designed to show you how to write equations of lines. The first few slides will deal with writing equations in slope-intercept form, and then we'll get into writing equations in standard form. So when you're writing an equation in slope-intercept form, which is y equals mx plus b, there's a variety of ways you can be presented the information. First, you can actually just be told what the slope and what the y-intercept are. So say you're given a situation where you're told the slope is 5, and that the y-intercept is -3, all you have to do is take those pieces of information and replace them in the spot of the appropriate variables. So the slope always takes the place of m, and the y-intercept always takes the place of b. You're done writing a slope-intercept equation when you have the slope multiplying x and something being added for b. So in this case, your equation would be y equals 5x plus -3. Your goal is to fill these empty boxes, and you can only do that when you know the slope and the y-intercept. Another way you could write that as an answer would be 5x minus 3. Anytime you have a plus negative, that's the same as minus. So in the last example, you were actually just given the slope and the y-intercept. You didn't have to find them. All you had to do was plug them in. So another possibility is that you're given the slope. Maybe the slope is 1/2. And then you're also given an ordered pair. So say the line passes through the point 0, 7. So a shortcut that you want to look at is when you're going to write y equals mx plus b, that missing b is the y-intercept. And on a graph, you know the y-intercept would be the place where the line hits the y-axis. So if you had a graph and then some random line, I'll just draw a random line, the y-intercept would be wherever that line crosses the y-axis. Some other things that you know about that coordinate is that if it's touching the y-axis, any coordinate on that spot, on that line, would have to have an x-coordinate of 0. So if you look here, because that ordered pair has an x-coordinate of 0, 7 must be the y-intercept. And if you can picture graphing that over here, you would go over to the right 0, and you would go up 7. So that would land on the y-axis, making it the y-intercept. So this equation would be y equals 1/2 x plus 7. If you can recognize having an x-coordinate of 0, you can save yourself a lot of time. So let's say this time you're given two ordered pairs. So maybe you're given the ordered pair 5, -3, and then 0, 2. Remember that your goal is to replace m, the slope, with a number, and b, the y-intercept, with a number. So this time I'm actually not given the slope, but since I'm given two ordered pairs, I have enough information to find it. So to find the slope, I could do 2 minus -3, which becomes plus positive, over 0 minus 5. So I end up with 5 over -5, which would give me a slope of -1. So at first I didn't have the slope, but if I use the y2 minus y1 over x2 minus x1 formula, I have enough information to get it. So far my answer would look like y equals -1x, which you could just write as -x, and then plus I still need my b. So I'm going to look back to my two coordinates, 5, -3, and 0, 2, and see if either of them falls under that trick we just talked about. If I plotted this one, it would be 5 spaces to the right and 3 down. That wouldn't be touching the y-axis. But since this one has an x-coordinate of 0, that means that 2 is the y-intercept. So I can just say y equals -1x plus 2. Another way that answer could look is just y equals -x plus 2. So this time you're given two ordered pairs, 4, 5, 8, 8, and again your goal is to find the slope and the y-intercept. So the first thing you would do is find the slope by applying the slope formula. 8 minus 5 over 8 minus 4, that's y2 minus y1 over x2 minus x1, and you end up with 3/4 for your slope. This time, if you look at your two ordered pairs, neither one of these ordered pairs would land on the y-axis because neither one of them has a y-coordinate of 0. So we actually don't know the y-intercept this time. So this time what we have to do is take the equation y equals mx plus b, and the objective is to find b. We don't know what that is, so I can't replace it with anything. But I did just find the slope, so I can replace that with 3/4. And then I can choose from these two ordered pairs what I want to replace x and y with. So I could replace x with 4 and y with 5, because those numbers are smaller. Or I could replace x with 8 and y with 8, which might actually be a better choice, because then if I accidentally mix them up, at least it's the same number. So then I bring down my plus b. So now I can actually do out 3/4 times 8, so if I put 8 over 1, the 4 would cancel and the 8 would become a 2. So that would get me 6 plus b. And then to isolate b, you'd minus 6 from both sides. So b equals 2. So now I have my slope and I have my y-intercept. But again, the goal is to write the equation. So I'm actually going to come up here and write y equals 3/4 x plus 2. That's the equation of that line. So let's say you're presented the information in function notation. The first thing that you need to do to start is to actually create two ordered pairs, and we're going to use what function notation is, which is f of x equals y. So if you actually, sorry about that. So if you match up just the numbers in the same spot, you can see here x is inside the parentheses, so whatever's inside the parentheses is x. So the ordered pairs would start with 1 and 4, and then whatever it equals to is y. So 5 and 14 are in the spot of y. So now I have my two ordered pairs. Now that you have two ordered pairs, you can actually just find the slope the same way you have in the past, which is y2 minus y1 over x2 minus x1. In this case, you get 9 over 3, which is 3. And then you can choose one of your two ordered pairs, so I'm going to choose this one, 1, 5, because the numbers are a lot smaller. I'm going to replace y with 5, m, the slope, with 3, I just found that, x with 1, and then I'm going to add b, because that's what I'm trying to find. So now you have 5 equals 3 plus b, 2 equals b. So then this time, for my final answer, I have y equals 3x plus 2. Now, since the information was given in function notation, you might see some people replace y with f of x. So that might say f of x, that symbol right there, equals 3x plus 2. But the process is the same. So the last situation to talk about is if now we're shifting away from slope-intercept and you're trying to write an equation in standard form. There's a couple things that you actually have to do first. So the first thing is you have to put the equation in slope-intercept form. And the reason is because we actually know how to do that. So you would start by finding the slope. So you do 5 minus 4 over 8 minus 5. That's y2 minus y1 over x2 minus x1. You're going to get 1/3. So then we'd find the y-intercept by taking y equals mx plus b. M is going to get replaced with 1/3. I can choose either point. So I'm going to choose to replace y with 4 and x with 5. So then I get 4 equals 5/3 plus b. To isolate b, I would minus 5/3 from each side. And then to do 4 minus 5/3, I can make it plus negative. And then 4 would become 12 over 3 plus negative 5/3, so b is 7/3. So in slope-intercept form, if that had been the target, the equation would be y equals 1/3 x plus 7/3. But that's just step one, so that's putting it in slope-intercept form. So then the next thing to do to start to get it into standard form is to move the x term over. So because in standard form, which is ax plus by equals c, x and y are on the same side. So to do that, I'm going to minus 1/3 x, minus 1/3 x, but then the order matters. I want the x to come first. So it's going to be negative 1/3 x, because that's the negative quantity, and then plus y, because y is positive, and then equals 7/3. So then once I'm there, the last thing to do is you want to make sure that a, b, and c are integers, which means you can't have any fractions or decimals, and that a is positive. So there's a couple of things we have to deal with here. Right now a is negative 1/3, so it's a fraction and it's negative, and c is 7/3. So I need to get rid of both the fractions by multiplying by 3, because 3 will cancel out with all those fractions. And then I'm also going to make it a negative 3, so that way when you do this negative times this negative, it's going to become positive. The reason we're allowed to do that is because you can write equivalent equations in standard form. You just have to remember if you're going to multiply something by a number, you have to multiply every single piece. So now it's almost just like distributing. So negative 3 times negative 1/3 x would be positive 3x. Negative 3 times y would be negative 3y. I could have just written that as minus instead of plus negative. Negative 3 times 7/3. The 3 would cancel, so it's going to equal negative 7. So that would be that equation in standard form.